This conference will now be recorded.
Okay, welcome to this lecture. Today we are going to discuss the states of the queuing system. The states of the queuing system, this concept is very important and useful for the discussion of the queuing system, because when we are going to discuss the derivation of the particular queuing model without knowing the concept of the states, it becomes very difficult to apply the mathematical derivation and mathematical treatments. So on certain stage of mathematical derivation, we have to apply the concept of the states, and therefore the states, about the states, to have the complete knowledge is a must for knowing the concept of the queuing system. So in this, under the queuing system, there are two important states. The first is known as steady state, and the second is known as transient states. Why we study the states? That is the very important question before us. We study the state because we wish to know the behavior of the system. As we know that behavior of the system, or if we try to understand the behavior of anybody, any system, any person, then it becomes very important to analyze and examine that very system for a long run. For a long run, what does it mean? There are two runs in our life in any system discussion. One is the short run and another is the long run. People used to say in our real life situations in our life that he or he is not a long run race, or he is not a horse of long run. He is not a horse of long run. वो लंबी रेस के घोड़े नहीं हैं. What does it mean? Why people say this very statement? Because during the long run, when time increases and the system changes with the change of time, then and only then we are able to assess the sustainability as well as reliability of the system. In the short run, it is very difficult to predict about the system, and therefore it becomes very important to analyze the system, to examine the various aspects of this system and their changes with respect to change in the time. Therefore, we study here the long run behavior of this system and short run behavior of this system. So the study of the system related to the short term is known as a transient state, and the study of a system which is connected with the long run, that is known as a steady state. So long run behavior, study of the long run behavior of a system is known as steady state, and study of a short run behavior of the queuing system is known as transient state. So what happens here? Long run behavior of the system in long run, we this very line is very important for us. If you try to see this very line, what we actually study during this study, during this discussion of the states of the queuing system, we wish to study, we intend to study the probability of n customers in time t for a queuing system. So this is very important, means this P and T is very important, and behavior of the P and T is going to be examined. And when we study the PNT, then now we will discuss further, I mean, under the different topic, that what are the performance measures of the performance, measures of the effectiveness, or measures of the performance of the queuing system. So measures of performance or measures of effectiveness, for example, the average queue length, for example, the average waiting time, for example, the traffic load, for example, the idle time of a server, for example, the variance of the queue, for example, this average number of customers in the system, for example, the service distribution uh, time. All these things are known as performance measures or the measures of effectiveness. These measures of the effectiveness are basically defined with the help of PNT. So in the root, in the core of effectiveness of the system, PNT is involved in each and every formula. When we start working to find out the formula, or to find formula is what? Formula is a measure of performance of the queuing system. So PNT, we cannot ignore the PNT. PNT is a main basis, and therefore we examine the PNT, and after examining the PNT, we can examine the M measures of effectiveness. Measures of effectiveness. In short, it is called MOE, measures of effectiveness. And that is also known as a measures of performance. Both terms are in parlance, both terms are in vogue, MOP and MOE. This is the purpose of study of the queuing system, to study, to analyze the MOP, measures of performance of the system, queuing system, and or the same thing, effectiveness is measured by the performance. Your personality is not effective, though you are looking very smart and everything, your dress is okay, your, the demeanor is okay, your external look is okay, but your working is not effective. Means that is the core, that is the heart of your personality, effectiveness. Do you create the effect or not? That is the main point. So in life or in any system, effectiveness is the most important aspect. And therefore, if we want to study the effectiveness and we want to measure the effectiveness, then PNT is involved as a main basis, because in each and every formula, the PNT is just like a function. If you want to calculate, the expected number of customers in the system, then En is equal to then sum over I, ranging from 1 to 0 to n, and n into PNT. Immediately the PNT comes, the Poisson distribution. And if it is time, then exponential distribution. So I mean to say the behavior of the system is studied under two possible states. You may say, you may ask one question that, sir, you are just saying that long run behavior and short run behavior, they are opposite to each other, and we have ignored the midpoint, middle behavior. So ordinary middle behavior is not a question of study. That is supposed to be a middle. There is no problem in its behavior, and therefore we do not study the middle one. And what is the middle one? When the behavior is established and you think upon about yourself, that once upon a time you were just in the first class, or in the junior standard, or the high school standard, or 12th standard, or the undergraduate standard, your thoughts were limited, your thoughts were immature, your thoughts were developing, You had been thinking something in the morning and you were thinking different in the evening. So thoughts were changing. Your elements and components, that is your core of the personality, was changing. But slowly and slowly, as time increases, your personality is going to be established. You take the decision on the basis of your previous decisions. You consult the persons who are taking the decisions. And I mean to say, you are going slowly and slowly, you are reaching the state of equilibrium. So this state of equilibrium is important for any system. Unless system is in equilibrium, it is very difficult to study and any prediction you cannot make. So for the sake of prediction, for the sake of measuring the performance of any system, including the queuing system, the behavior study, in particularly the short run time and the long run time, is a must. So therefore, these are two important states in the queuing system. If you remember, already I have given some brief lecture on this, but I would like to give on this the full lecture. I mean, complete. You must have the complete knowledge about this. So, short run and long run behavior are important. I just pointed out, with respect to time. This is very important. Now, they are functions. Since we are the mathematicians, we are making the mathematical study of the gating line or the queuing line or the queue. Therefore, we must have the performance measure or the probability measure here. So function is they are pivotal function are the key function in the analysis of the queuing system is this one. This one, it is our hero, you guys, main character in this discussion. So we will focus everything around this PNT. It is the main character or the main element of the discussion. So short run behavior of PNT, let us discuss the PNT, implies how PNT varies when T varies, but it is in the beginning of the system. T varies means no doubt T is taking variation in T is taking place, but the system is in the short run. I mean, this has system has booting itself, booting, or you can say rebooting itself, starting itself. So in the start, there are certain instability, there are certain variations, and therefore we cannot say that it is a stable state, but we say, call it, we name it the transient state. Why this is a transient state? Because with the change of time, the behavior of the system is changing. Where stable or constant condition is not reached. This is a, therefore this is a transient state. So if you are testing some behavior and you have not reached any stable point, then we call it, we name it the transient behavior. We call, now still we are in the transient behavior, transient mode, and therefore I can't say anything. So prediction is very difficult in this state. And therefore, mathematically, what you will say, how it is difficult mathematically to have derivation about the transient state is very difficult. Reason is what? N is a variable, T is also one variable. T is also one variable. This has become two variable function, and handling the two variable function becomes difficult as compared to the single variable function. And therefore you won't find the number of research papers related to transient state, but we will find numerous plethora or you can say myriad number of researches under the steady state. Reason is that the mathematical analysis, mathematical treatment, considering the transient state of a function, probability function, becomes difficult to solve. And therefore, we have lesser and lesser number of researches involving the transient state. So for the scope of research, it is a very important state. And if we are able to solve any problem involving the transient state, so the persons who are involved in the field of this operation research or the queuing system, they immediately understand that this paper has definitely some value that is readable. It must have the wide readability, it must have the wide accessibility, and therefore it gets it gets the place in the publication as sooner as compared to the steady state. But this requires long and deep practice of knowledge. Then and only then we are able to solve such problems. So this is the scope of the research I told you. Though it is not good for at the MSc level, but its behavior is good for the research level. Therefore, I have requested my esteemed research scholars to join my lecture, because I also used to indicate the scope of the researches behind this. So mathematically, what we do, we analyze it mathematically. What mathematically analyze are the limiting behavior. Again, we have come to the very favorite topic. Your very favorite topic is the limiting behavior of a system. And if you again just enter into the discussion of philosophy of the limiting behavior of a system, again you can consult today what is the limiting behavior of a function and why we study the limiting behavior of the function. Limiting behavior of a function, here we want to see the limiting behavior. I mean to say t is going to be very, very large. So limiting behavior. Limiting behavior can ensure the stable property of the system. Here the queuing system. Unless we analyze the limiting behavior, we cannot reach the stable condition or the steady state. So it is important, the limiting behavior is very important, and limiting behavior when the variable time duration is going to be very large. Very large, you will say. Very large means continuously a queuing system must operate continuously 24 into 7. It should not close. You will say like this, t is going to be very large means infinity. No, not that. It is that if doctor sits in the morning 8 o'clock and he gets up in the evening or afternoon, he leaves the system in the afternoon around 2 o'clock, that very time is a total duration. So when he sits in the beginning 8 o'clock, if you talk about the 8:30, if you talk about the 9 o'clock, if you talk about the 9:30, if you talk about the 10 o'clock, this state is what? This state seems to be the transient state. Transient, people are coming, hustle and bustle. Hustle and bustle is there. System is going to be established. People are coming, people are just waiting. So this is a transient state, but when it is going to be 12 o'clock, now it is going to be just like 12 o'clock, 1 o'clock, then it is going to be stable or the steady state. At that time, T is going to be very large. Here, infinity does not mean that the system must continuously working 24 into 7. It should not be closed like this. Some of the interpretations may be given like this, but it is server. If server is a human being, how you can say, at most we can say the shift of the doctors changes. Shift of the doctors changes. So if shift of the doctor changes, then it is sometimes it is the end. In the morning emergency, in the night emergency is going on. So it is working continuously, no problem, it is working continuously. But if you define a slot, 12 o'clock in the night and 10 o'clock in the morning, this is the total slot. We have to define the t tends to infinity, means t tends to infinity in that very slot. Here infinity does not mean that infinite amount of time. Infinity means in the given situation very, very large. Not, we have to think that any person is saying, and you are a mathematician, he is putting a question or she is putting a question, how you justify t tending to infinity? Because infinity is not reached here. So no and never this kind of question is applicable here. That question is replied in the way, in a very simple way, that t tends to infinity means t is going to be very, very large in the given duration of the time. So I told you in the beginning 8 o'clock, 8:30, 9 o'clock, this is a transient state. But when it establishes, when doctor is doing well and para staff is doing well, the equipments are on out of the waiting time, and everything is active and process is going on without any disturbances, without any hampering the states or process, then it is a state of equilibrium, and that is known as a steady state. So what happens in that this state? If you define here t tending to infinity, that is increasing, it does not hold for the transient state. Here you look at this very definition. Mathematically I have tried to show this part, but this does not hold true. Means t does not reach infinity, means very, very large, and therefore the pnt is pnt. I mean, this behavior, T is not detached from here. T is dependent. The Pn is dependent on T. Here, it is also dependent on T. Meaning, thereby, this time, if you are increasing means P started from T is equal to 0. So T is 0, something, 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 increasing. But that increase is smaller as compared to increase in the stable system, or is the steady state system, and therefore this is dependent of time. This state is known as a transient state, but not affected when we analyze the long run behavior of the system with respect to time. It means that now system is not going to change after this long time. Means a smaller time is not going to affect the transient states. What happens in the long run? Long run is studied because after a long run, after a long time, with respect to time, the system is not going to change. And if system is not going to change, so what is the advantage that system is not going to change? System is not going to change, it means now it is stable. Equilibrium, we are reaching the state of equilibrium. A steady state means a state of equilibrium, the same thing. We have already a state of equilibrium. The state of equilibrium. A state of equilibrium. Yes. A state of equilibrium. This is the state of equilibrium. And we can use for prediction. Then and only then it is possible to say something about this. Otherwise, a measurement of performance. Then people will try to understand if something is stable, something is peaceful. If it is unrest, we can't say. This time we are living in the unrest time, transient state. This the COVID-19 is a state of transient. This is not a stable state. So we are just waiting for the stable state. With the changes of time, what the COVID infection is taking place, it is a transient state, a good example of the transient state. So any prediction is not possible to make about the performance of the system. So this is known as a steady state behavior. So long run study is a must, or limiting behavior of a system is a must. How we define this? Let us examine probability of n customers in time t for a queuing system whenever t is going to be large. T is going to be very, very large. This is known or named as limiting behavior of P. This is the limiting behavior of the PNT when time is going to be large. And in case of limit, what we do, sometimes the variable tends to be very small, sometimes the variable is going to be very large, x tends to infinity, x tends to 0, and sometimes x tends to a point. A means it is very, very close to the neighborhood of A. Then we take the limit there. So there are three important conditions, if you remember. One is it is going to be very, very large. One is it is going to be very, very small. One is it is going to be very, very close to the neighborhood. When we say that x limit x tends to A, it does mean that x does not approach it approaches A, but it is not equal to A, because if you reach equal to A, so we do not talk about the limit. So in case of limit, means it is an assumption that we do not reach the point, but we reach in the neighborhood of that point. So when we say t tends to be infinity, so it is we are not reaching the infinity. When we say tends to 0, and we are not reaching the 0 but near 0. When we say n tends to some quantity, means we are going to be very, very close to that, but we are not equal to that. If you are equal to that, then concept of the limit fails, because limiting behavior is such kind of behavior where infinite number of points are available in the neighborhood, and if you reach that neighborhood of a large quantity, a small quantity, or any finite quantity, then and only then we talk about the limiting behavior. So it is very interesting point in the mathematics. You look at this very point here as a mathematics. Limit n tending to 0, and not n time it is required, it is t. You change it.
Just t tends to 0. T tends to infinity.
Yeah, t tends to infinity means it remains Pn. Even that here, independent. This has become independent of time. This is very important. But here, the mathematicians say that this is only possible. I try to give you one interesting interpretations of this steady state. I discussed this very point as a reason of the farm. If you just reminisce, remember your past, then I told you, and you also discussed with me in class, that the formation of Q is made or takes place when lambda is greater than mu. arrival rate is greater than the service rate, then and only then the queue is formed.
Yes, sir.
Only is formed. This is the reason of the formation of the queue. Okay.
Yes, sir.
This was the reason of the formation of the queue, and therefore, when a steady state is formed, when we reach the steady state, what happens? In a steady state, what happens? That service, this condition changes, and this condition is reached. And whenever mathematically you apply the steady state, it is given the condition that lambda upon mu is always less than 1. This is the condition of the steady state. What happens here? That we focus on the service. Your service has become so smooth and stable that now we are not bothering about the arrival of the customers. Our focus has been shifted. Our focus has been shifted Our focus has been shifted from arrival to service, and therefore now this question does not arise that lambda is greater than it. It is a condition of the formation of Q in the beginning. It is not a condition of the steady state, because system has already run for sufficiently large time, and thereafter the steady state has come. Therefore, you should not keep in the mind some experts, some professors may can question this way, that how you are going to violate your basic, very basic and fundamental condition of the formation of the Q in the steady state. So this has to be answered in the way that the steady state means that system has already run for sufficiently large time, and therefore in the beginning this is a condition that has to be satisfied, but later this condition takes place in the steady state. So this point is very important. Keep in your mind. I will give you time at last to discuss. So keep reserve your questions. Last, I will entertain your questions. So if you have any doubts, you look at this and this graph. It was not shown by me in the previous lecture. You look at this graph. Here is the time. Here is the time in the lower case, and you just look at upper part. This y-axis has PNT, and naturally PNT means with the help of PNT we will also measure the effectiveness or performance measures. This is the main purpose of studying the Q, is we are measuring the performance of the system. And therefore a steady state is this one when there is no change. It is smooth, it is smooth, it is smooth, there is no change. But here there is a change in this graph. You look at here, the fluctuation is very high in the transient state, and look at here, this is a time. This is a time, then time, according to time, this beginning of the system, this much is the transient state. And after this system is a steady state. So always we wait for the stable state. It is the human behavior to reach in the human state, so that the system can produce the maximum performance. The system can produce the maximum performance here when the system has become steady in the equilibrium state. And if system is not in the equilibrium state, then system itself is maintaining its stability. It is quarreling with itself. It is clashing with itself to reach the steady state here. And if you go, doctors are going to sit, they are just giving the instructions to the nurses, to other things, to other staff. He is going to just instruct for making all the machines ready. And during that time, if you reach there and say that you just check up me and I am in hurry, they are furious. They get furious that they say, just wait. Now it is going to start, just wait. Now it is going to start, just wait. As the government is saying that you just remain in your house, be safe in your house, just wait. So you can't say. But one thing is very clear here. If you are productive, if you are performing well in the transient state, then you are exceptional. Though everybody is trying to have the steady state, but in this situation, if somebody is performing, if some system is performing, then that is the rare thing. And that is why in the researches, the transient state is very important. When in the disturbance, you are not disturbed and doing well, that is the real personality and real system. So it is one way of interpretations, and you may have or somebody may have different interpretations. We must honor, we must agree to disagree. We must agree to disagree. If we listen the another side and we are not just agreeing, then at least we must agree to disagree, that I do not agree this point, but you may be right. Further, we can say that you just here look at this very point, and this very point we are going to we are going to utilize in the queuing model, the next lectures, and therefore these concepts are very important here. What is this in transient state? If you take, you have got the probability differential difference equation, if you remember. So we have probability differential difference equations. So naturally, if it is the differential equation, say d dt, we cannot ignore. So it will exist in the expression, and therefore, if we want to apply the states, suppose we are going to study under the transient state, and somewhere we are finding P and T, and you just differentiate with respect to this. So I mean to say you will get, this is differentiation, after differentiation P dash D, and you will get something here, something here you will get, but something here you will get, and maybe further involving the T, maybe further involving the T. There is no assurance that it is going to be free from T in case of transient behavior. You look at, so this may be this may be a complication here. Complication means it may not be going free from the T. It may be involving the T, and therefore the further analysis or the process of getting the solution may be intricate, or sometimes this kind of solution may be phenomenally intricate. Phenomenally intricate means very, very difficult and complex. You just compare it with the steady state. These properties we are going to study, and it is a matter of great satisfaction for the students of the MSc level that we have in our course curriculum only the steady state mathematical derivations. We do not have the course related to the transient one. So you must be happy to learn this very state, that whenever we take the first derivative of the P and T in the expression, so ddt, and if n tends to this ddt here, naturally condition you know, the n tends to, the t tends to, here t tends to infinity every time this. So this P and T, T tends to infinity, what it becomes Pn. It is free from T, and therefore this becomes free from T. This is just like a constant quantity, and when you take the first derivative with respect to T of any constant quantity, it tends to be zero or it is equal to zero. And then the expression, wherever it is, P and T in the left hand side, in the right hand side, in the between, the everywhere you will find zero. And the very big expressions, very long expression, reduces to be smaller one, and we are happy to solve it. So this is a mathematical advantage. This will be, I have mentioned this very point. We will use this condition in mathematical derivation of new models. We are going to rigorously involve in the mathematical, Keying models, after this state discussion of the state. So there are two important remarks at steady state. The average Keying performance, you look at here. Average Keying performance turns constant, means whatever we say, average number of customers in the system, in the queue, average waiting time, the idle time, and what we say, the traffic load, whatever we say, that is stable, that is a constant. There is no very significant or substantial variation in this performance. So now you can be your owner of the factory, your owner of the system, can say now things are going smooth and everybody wants to have a peace and smoothness in the life. It is a matter of research that what we want in our life. And second point we have already discussed, it is less than service rate, that is lambda is less than mu, lambda mu is less than, this is the steady state. So what is the conflict? Conflict is that lambda is greater than mu. This is the formation of Q in the beginning, but it is not in the beginning, it is a long run behavior. It is a beginning behavior. Lambda is greater than mu is a beginning behavior. Therefore, if somebody is going to confuse us, so we must be mindful and beware of this kind of trick to get us confused. Now you just your knowledge, to just expand your knowledge, I have taken here the different dimensions where the steady state or the state of equilibrium is important for us. From very beginnings, in case of physics, you may remember that we have studied the state of equilibrium or the steady state in physics, in engineering, and not only physics, engineering, but in economics also. The steady state is the state of equilibrium is very important. Here in physiology means our science of our body, that is the Mano Sanrachana Shastra. Physiology, it is studied, it is named as, it is very surprising to know, you will wonder the process which is undertaken by our own body, our sharir, is the homeostasis. Homeostasis is a steady state of the body, or the state or a property of a body in which the internal state of equilibrium, property of a body, what does it do? You look at here, the where internal environment of the body itself maintains. You are surprising, you are doing excess with your body, but your body is, some virus is attacking your body, so your body does not surrender. In any you are under stress, you are under tension, you are very, very angry, you are sometimes very, very lusty, then in that situation your body controls yourself, and that control is 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 maintained in the steady state or the state of equilibrium, and this very state is very popularly known as homeostasis. You must remember homeostasis, never forget homeostasis, not statistics, homeostasis. Otherwise, you will say homeostatistics, then this will change the meaning itself. What does it do? This maintains the various vital parameters of your body. Our body, what are the vital parameters? Just like temperature. The body always controls itself, maintains itself, regulates itself, that your temperature of the body should not increase, should not decrease. It must be maintained in ideal level. What is this ideal level? And fluid levels, if there is a shortage of the fluid in body, and many of the persons do not drink the sufficient water, sufficient fluid, sufficient, they like always dry things, then the body, the homeostasis process maintains and regulates the fluid in your body. It takes the fluid from your reservoir, your reservation part, maybe even your blood, and that the shortage of the fluid is maintained by the process or the state of the homeostasis by this property. And what hormonal secretion? When you are very angry, then you release the hormones, chemicals, a dangerous chemical, poisonous chemical. So that is stopped, immediately stopped by the body, and it is controlled. Hormonal secretion, normalizing pH values, body pH. pH is always, it is slightly alkaline. Our body is slightly alkaline. This is more than 7.2 or something. There is an optimum pH of the body. So this pH is always maintained by the body itself. It has property of body itself to maintain the state of equilibrium or the steady state. But here is steady state is well known as homeostasis, and therefore this is also important in economics. We study the steady state because the derivatives are there, and then we use the prediction in the economics. In the transient state, it becomes very difficult. In engineering, everything is studied in the engineering, and maybe chemical engineering, maybe mechanical engineering, maybe civil engineering. Everything is required for the steady state. In the physics, we have already studied this concept of the equilibrium, and we have also made several experiments, if you remember, of the physics to maintain the equilibrium, etc. In this way, so a steady state is not only working, is not only important to be discussed under the Keving system, but this is also a very useful concept in other branches of science and disciplines. And in this way, I think it is today enough to complete this lecture. And so I would like to open this lecture for the query, and then